In this problem, they're asking us to find the number of atoms of a specific type in each of the compounds they list, and they give us the mass of the compound that you have on hand. So this is a stoichiometry problem. We'll use the molar mass to go from mass to number of moles. Then we'll use Avogadro's number to go from moles to the number of molecules of each type. And then we need to know the formula for each of these compounds, because we'll go from the number of molecules of each type to the number of atoms of nitrogen. So what they're asking us is atoms of a specific kind in the compound. So starting with number A, glycine. This is the only one that they give us the formula for. And I presume that you can look up molar mass pretty comfortably at this point. C2H5O2N, I would look up 2 atoms of carbon, 5 atoms of hydrogen, 2 atoms of oxygen, and 1 atom of nitrogen, and multiply the atomic weights by the number of atoms of each type. It works out to be 71.0 grams per mole. So just jot that one down. So 71.0 grams per mole for glycine. The other molecules here, magnesium nitride is Mg3N2, and its molar mass is 100.3 grams per mole. Calcium nitrate is Ca, and then open parentheses NO3, close parentheses 2, and that is 164.1 grams per mole. And dinitrogen tetroxide, N2O4, is 92.0 grams per mole. Okay, so if we work out the problem for part A, for the glycine, they tell us that we've got 8 grams per mole, or 8 grams of the substance, and the molar mass is 71 grams for every 1 mole. And 1 mole of any substance, regardless of what it is 6.022 times 10 to the 23rd molecules. In this case it's molecules, but it could be atoms or ions or whatever. And then look carefully at the formula. 1 molecule of C2H5O2N contains exactly 1 atom of nitrogen. That is, the subscript for nitrogen within the molecule is a 1. So on my calculator I would multiply 8 times 1 times Avogadro's number times 1, and then divide all that by 71. It works out for part A to be 9.61 times 10 to the 23rd atoms of nitrogen. When entering into WebAssign, I would just type in 9.61 lowercase e 23. Next one is magnesium nitride. My red number was 8 grams. The molar mass of magnesium nitride is 100.3. And the setup is almost identical in this problem as the last one. If you look carefully at the formula for magnesium nitride, Mg3N2, you see that there are 2 atoms of nitrogen. This is really important for getting the right answer to this problem. That is, you're going to find the number of molecules of magnesium nitride that you have on hand, or technically, since it's an ionic compound, you don't use the word molecule, you'd say formula units, but that's not important at this point. You have a certain number of formula units or molecules of magnesium nitride, but then you've got to double it to get the number of atoms. So if you crunch all the way across here, I'd say 8 times 1 times Avogadro's number times 2, all divided by 100.3 times 1 times 1. So that works out to be 9 point... Oh, wait. The answer up above, excuse me. This wouldn't necessarily matter unless you happen to have my red numbers. This answer is 9.61 times 10 to the 23rd atoms of nitrogen. The one from up above is actually a different number. Trying to erase this. This one is actually 6.79 times 10 to the 22nd atoms of nitrogen. B's answer is correctly written as 9.61 times 10 to the 23rd. Okay, part C, they're asking us about calcium nitrate. We've got 8 grams of it. The molar mass of calcium nitrate is 164.1 grams. And just like the parts A and B, we'll use Avogadro's number to get the number of molecules, or technically you would call it formula units, not a big deal, to get 2 moles of calcium nitrate. But if you look carefully at the formula for calcium nitrate, for every 1 molecule there are actually 2 atoms of nitrogen. And so you've got to take double the number of molecules of calcium nitrate to get atoms of nitrogen. And in my case, for my red number, it works out to be 5.88 times 10 to the 22nd atoms of nitrogen. Part D, they ask us about dinitrogen tetroxide, N2O4, the molar mass of which we had established was 92 grams for every 1 mole. And once again, you'll be multiplying by Avogadro's number in the numerator. That gives you number of molecules for every 1 mole. And then within N2O4, for every one of those molecules, there are 2 atoms of nitrogen. And I know that because of the subscript 2 in the formula, N2O4. So that works out to be 1.05 times 10 to the 23rd atoms of nitrogen.